Hello everyone, welcome back. Today our topic is arithmetic progression. Now this topic is easy, okay? Here in this session today I am going to take variety of questions and I'll give you some tips and tricks to get out of marks for this topic. Alright, so watch the video till end. Now, when I talk about arithmetic progression, that comes under series and sequences. Now, what are they? So, they have some certain number patterns. Alright. Now, arithmetic progression is a list of numbers when I take the difference of the two consecutive terms, it is always same. Alright. So, let me take some examples. Let's say 2, 4, 6, 8, 10 and so on. Okay, so every term, two consecutive term has common difference, which is I am adding plus to every time, correct? So this is arithmetic sequence progression. All right, one more example if I'll take, so let's say 3, then 2.5, okay, 2, 1.5, so on. So here the common difference is, see, I have to take this second term and then subtract this. So common difference is minus 0.5, okay, like this. So this is the common difference, the fixed number which we are adding to get the next term. Alright, so it can be positive, it can be negative or 0 also. For example, if I'll say 5, 5, 5, 5 and so on. So this is, here every time we add 0, right? So this is also the constant arithmetic progression. Now, the general term of the AP. Now, arithmetic progression, in short, it is called AP. Alright, so general term is given as Tn, or sometimes it is denoted as An. Okay, so Tn or An is equals to A plus n minus 1 into D. Now, what are this? So, this is nth term. Tn is nothing but, let me write, Tn is nth term. Okay. Then A is the first term of the sequence, and D is the common difference. Alright. Now, when there are finite number of terms, means which you can count, so that is called the finite AP. And infinite number of terms, the progression is called infinite AP. Alright. And for infinite AP, we don't have the last term. Now, let's take some example and understand. So, we have to write the first term and the common difference for the given AP. Now, how to find the common difference? So, common difference, first of all, I can simply say the first term, right? First term is 0.6. Now, the common difference is equals to 1.7 minus 0.6. So, this gives me 1.1. It is same everywhere? Yes, it is, right? If I'll just take the difference of this, I'll get 1.1 every time. So, I got my answers, right? Alright, super easy. Now, for the next question. So, first term is 3. First term is 3 and the common difference. So, D is equals to, I'll take the second term first. So, 3 plus square root 2 and then subtract the first term. So, what I'll get? Square root 2. So, we got the first term and the common difference. Now, if the pth term of the AP is this, okay, then we have to find AP. Alright. So, AP is equals to 2P plus 3. Alright. Now, we have to take the value of P as 1, 2, 3 and so on, because we are talking about first term, second term, third term and so on. Right. So, if I'll put P equals to 1, what I'll get? A1 or simply A is nothing but 2 times 1 plus 3, which is 5. Then A2, which is 2 times 2 plus 3, which is 4 plus 3, 7. Correct? And if I see the common difference is 2, so I can easily write the next also. It would be 9, but let's check. If I say 2 times 3 plus 3, so 6 plus 3 is 9. So yes. So the AP is what? 5, 7, 9. What would be the next term? 11 and so on. Right? Great. Find the 50th term of the sequence. Alright. Now we can say the first term. So A is equals to 1 over n. And the next term. So what I can say? A2 equals to n plus 1 upon n. When I take the difference, okay, so common difference is equals to A2 minus A1. This gives me n plus 1 upon n minus 1 upon n. And if I simplify this, I'll get just 1, right? So the common difference is 1. The first term is this. Now I can find the 50th term. So A 50th is equals to A plus 50 minus 1 into D. So what I'll get? A 50th is equals to 1 upon n plus 49. D is 1. So this is just my 50th term. And if I want to write in this term, so I can write 49n plus 1, correct, upon n. I can write this way also. Okay, anything is fine. If you write this or this, anything is fine. See the pattern here. See, first term is just 1 upon n. Second term n plus 1 upon n. Third term is 2n plus 1 upon 10. So I can predict, right? 50th term is 49n plus 1 upon n. And if I'll ask you 100th term, so it is 99n plus 1 upon n. Correct? Alright, great. Now here in a flower bed, there are 23 rose plants in the first row. Okay, 23 rose plants in the first row. Then 21 in second. Okay, so next term is 21 and 19th in third row. So 19 and so on. And there are 5 rose plants in the last. So it ends with 5. How many rows are there in flower bed? So we have to find how many terms are there in AP, because this is AP, right? If you see, the common difference is minus 2. So I'll write it. Okay, the first term is 23. Common difference is 21 minus 23 is minus 2. So I can find, now my nth term is given. Okay, nth term is 5. So an is equals to a plus n minus 1 into d. Now I'll substitute all the values which are given. So last term is 5. First term is 23 plus, I don't know the value of n. So I'll write this into minus 2. And now let's solve this. So what do we get? 5 equals 23 minus 2n plus 2. And on solving this, I'll get, yes. So n equals to, let's write this first. Okay, 25 minus 2n and n equals to 10. So there are 10 rows of the flower beds, right? So you have to write the final answer, correct? Now here it is the interesting question. So see, Tn is the nth term, okay, and they have given that T2 plus T5 minus T3 equals 10. That means what? Second term plus fifth term minus third term equals to 10. Also they have given that T2 plus T9 equals 17. Means second term plus ninth term equals to 17. Alright. Now what is the general term? Tn equals to a plus n minus 1 into d. So we'll substitute it. Okay. Now see how I write it efficiently. So my first term, okay, a. Now second term, so n equals to 2, 2 minus 1, I'll get 1. So a plus d, the second term. Similarly, the fifth term, so I can say a plus 4d and minus third term. So a plus 2d, I have to subtract. This gives me 10. Now on simplifying this, so I can cancel out a and then 5d minus 2d. So I'll get 3d. So a plus 3d, which is equals to 10. I got the first equation here. Now if I'll simplify this, okay. So again a plus d plus a plus 8d equals 17. Alright. And on simplifying, what do we get? 2a plus 9d equals 17. Now you have two linear equations, right? We know how to solve them. So I'll multiply this equation by 2 and I'll use the elimination method. So 2a plus 6d equals 20 and 2a plus 9d equals 17. Now we'll simplify this by subtracting. So what do we get? Minus 3d equals minus 3 and d equals to 1. So I get this value, right? Just a moment. This is plus and I'll get minus 1, right? Yeah, d is equals to minus 1. So the common difference is negative 1. And now on putting d's value over here, I'm putting it here, okay? So a plus 3 into minus 1 equals 10. So a equals to 13. So this is the first term. So we got the first term and the common difference which were asked. Alright. Find the 10th term from the end of the AP. Okay. And AP is given. So let me write this. 4, 9, 14 and till 254. So here the first term, okay, is 4. So first term from start equals 4 and the common difference is equals to 9 minus 4, which is 5. Now when I talk about the from the end, okay, they are asking from the end. So what I'll take, we have to go reverse way. So the first term from the end, okay, I'll write that way. First term from the end equals 254. And when I go reverse way, the common difference becomes what? Yes, negative 5, which is important, okay. Why I have taken negative 5? Because from end, okay, we are taking from end, reverse way. Alright, remember this. So I got the first term and I got the common difference. So I can find the 10th term from the end. So what I can say, 10th term from end equals, I'll apply the general formula, okay. So a plus n minus 1 d only, and here a is 254 plus 10th term. So 10 minus 1, I'll get 9 times minus 5. So this is nothing but 254 minus 45 and I'll get 209. So this is the 10th term from the end. Clear? Great. Now here in this question, the third term and the 9th term of AP are given. And we have to find which term of the AP is 0. Okay. So we have to find for which value of n the term is 0. So let's write this. So I'll start with 9th term. Okay. So T9 equals to A plus 8D and that is equals to minus 8. Also we are given that T3 equals to A plus 2D equals to 4. Now I can use the elimination method to solve them. So on solving it, what I'll get, 6D is equals to minus 12 and D is equals to minus 2. So the common difference is minus 2. On substituting it on any of the equation, we'll get A equals to 8. Correct? So we got the first term and the last term. Now the second part of the question. So we have to find the value of n where the Tn is 0. So Tn, let me write the general term. So 8 plus n minus 1 into D. D is minus 2. So this is the general term and they have told us that is 0. Now we'll simplify this. So what do we get? 8 minus 2n plus 2 is equals to 0. And on solving this, I'll get 2n equals to 10, n equals to 5. That means the fifth term is 0. The fifth term is 0. Alright. Now see how you verify it. See, it is easy to verify here. 8, then the next term. See, common difference is minus 2. So 6, 4, 2, 0. Right? So we got the fifth term 0. Right? So this is how you can verify also. Alright? Okay. Very interesting question. Now, how many 2-digit numbers are divisible by 3? So, see, they are talking about 2-digit number. So, first 2-digit number which is divisible by 3 is, yes, 12. The next is 15. Correct? See, 3 is stable, but as we need 2-digit first. So, I'll start with 12. Alright? And I'll keep on adding 3 to get the next number. Now the last 2-digit number which is divisible by 3 is how much? Correct. 99. So I have these values and I have to find how many are there, means the number of terms, and we have to find. So let's now write all the stuff. So A equals to 12. Common difference is 3. Okay. And we have the nth term. Okay. Tn is equals to 99. Now I can find the value of n. So Tn is equals to n 12 plus n minus 1 into D. So D is 3 and this is 99. So when I simplify this, so what do we get on simplifying? 12 plus 3n minus 3 equals 99, and when we solve them, what do we get? N equals to, let me write, 3n equals to here 90 and n equals to 30. So there are 30 numbers, 2-digit numbers, okay, 30 2-digit numbers which are divisible by 3. Perfect? Yes. Okay. Now we have to find the value of k for which these 3 terms are in AP. Okay. So these are the terms of AP. Alright. Interesting question. So see what we know, the common difference. Okay. Common difference is what? an plus 1 minus an. We know that. So the next term minus the previous term. Alright. So I'll write this as 2k square plus 3k plus 6. Okay, minus, I am subtracting the first term now. So k square plus 4k plus 8. And when I simplify this, what do we get? K square minus k minus 2. So common difference of these two is minus 2. Okay. Now same way we'll find the common difference of these two. So let me write this. The common difference again is what? 3k square plus 4k plus 4 minus 2k square plus 3k plus 6. And when I simplify them, what do we get? K square plus K minus 2. Okay, so uh, here it is the K square minus K. Okay, I'm sorry, I forgot to write this. And here it is K square plus K minus 2. So these are the difference. Okay, so here both should be same because they are in AP, correct? So what I can write, K square minus K minus 2 equals K square plus K minus 2. And on simplifying this, what do we get? 2K equals 0 and hence K equals to 0. So this is a value of K. So nothing was there in the question, just it become, it seems to be complicated just because of this quadratic uh, expression, right? All right, so next session we'll learn about the sum of the terms in AP. All right, I hope you understood this, and if you have any doubt, please comment so I can help you out. Thank you for watching.